This course is a preparatory course designed to introduce you to the basics of filtration. You'll learn some of the terminology frequently used in the industry, and you'll become familiar with the basic components and function of filters. You'll also learn about the different types of filtration media and how and why they're used. By the end of this course, you will understand the importance of filtration, and you'll have learned some of the terminology used in the filtration industry. In addition, you'll understand the different types of media used for filtration and why each type is used. You'll also understand the component parts of a filter and the function of each of those parts. All of the air, fuel, oil, and water flowing through an engine contain a variety of contaminants from various sources. These contaminants, like dust and sludge, cause wear on engine components and shorten the life of the engine. The function of a filter is to remove that unwanted contamination and lengthen the life of the engine as long as possible, reducing total operating costs and saving you money. Harmful contamination exists in each system in the engine. These photos show just how serious the buildup of contaminants can get inside an engine. Different systems within the engine are affected differently by contamination. Airborne contaminants differ greatly from those found in oil, both in size and substance, for example. Regardless of the system, contamination can cause premature wear to precision parts and lead to engine failure. There are three sources of contamination. The first is just the contaminants produced by normal wear that's expected in equipment with moving parts. This type is called self-generated. The second type is contamination brought in from outside sources, like dust in the air intake, for example. This type is called ingested. The third type is the contamination that already exists in a system or in the fluids added to that system. When the oil is changed, for example, the new oil could contain a low level of contaminants. This is termed built-in contamination. It is the purpose of the filter to remove particles of a given size range from the fluids within the engine. Filters are rated by the size of the particles they remove. This rating is the efficiency of the filter. Filters with poor or low efficiency only filter out larger particles, allowing smaller contaminant particles to stay in the system, causing increased engine wear. On the other hand, filters with greater or high efficiency remove much more contaminant, but can plug quickly, giving the filter a short service interval and causing increased maintenance costs. The weight of the maximum amount of material removed from a fluid and held by the filter is known as the filter's capacity. Filters have the capacity to hold a certain amount of material, and that capacity is designed to be greater than the amount of contaminant generated for a specific period of time. This given period of time is the system's service interval, or simply put, the time between filter changes. As you've learned, filters are rated by the size of the particles they remove. The particulate size is measured in microns. A micron is 1/1,000,000th of a meter, or 394 10/millionths of an inch. In the illustration shown here, you can see that a bacteria is 2 microns in diameter, and a white blood cell is 25 microns in diameter. The largest particle that can pass through a Fleetguard full-flow lube filter is 40 microns, which is still smaller than the 50-micron diameter of a human hair. So, how are these filters constructed to remove such tiny particles? Inside the filter housing is a center tube surrounded by the filter element or media on the bottom and the stacked disc bypass media on top. The filter connects to the housing by means of a thread plate or nut plate, which provides the connection point between the mounting base and the filter. The gasket keeps any fluids from leaking out. Now, let's discuss some of these parts in more detail. The filter element or media is the working part of the filter. It removes the wear-causing contaminants from the fluid flowing through it. Not all media is made of the same material, though. Medias can be made of either natural or synthetic materials. Each type of media performs a different function, depending on the requirements of the application and the maintenance practices used for that application. Cellulose or paper is a natural material and is the most commonly used media material. Synthetic media can be made from glass or various polymers and is not as commonly used. Cellulose filters have been around for quite a while. They are considered an older technology and are used when high efficiency or long-term filtration are not the main concern. Cellulose is the most inexpensive media type used in filters because paper is inexpensive and produced in large volume. Cellulose fibers are made of wood pulp and are irregularly shaped. The fibers are also larger than synthetic fibers. These two factors cause high restriction in cellulose media. Take a look at the microscopic view of a cellulose filter. Keep that in mind as you view the next couple of slides. Synthetic media was developed to meet the need for a high-efficiency, low-restriction filter. Fiberglass was the first synthetic media used in filtration. Notice that the synthetic fibers are smaller in diameter, more regular in shape, and denser than cellulose fibers. Cummins Filtration was the first company to develop a glass fiber media for use in an engine lube system. This product was named Microglass. Microglass media has a much greater capacity and efficiency than a comparable cellulose filter, yet has a much lower restriction. It makes sense because the fibers are smaller in diameter than cellulose and are round when viewed in cross-section, as you've seen. Glass media, however, is delicate and can't stand up to high flows. That's why it must be layered with other materials, generally polyester, to make the media usable. Today, there is a new generation of synthetic media. Stratopore media is made using a melt-blown process, and polymers are used as the base material instead of glass. Stratopore is a patented media developed by Cummins Filtration and has a micron range from 2 to 25 microns, depending on the application. Compared to the average 40 micron rating of cellulose media, Stratopore media delivers much greater performance. Both glass and Stratopore media have straight, round fibers that provide high efficiency and high capacity with low restriction. Also, like glass, Stratopore is a layered media. That's where the similarities end, though. Unlike glass, all the layers of Stratopore media are used in the filtration process. Each layer acts as a separate filter, each with a smaller micron rating. This layered construction gives the Stratopore filter a gradient density, filtering out finer and finer particles as the air or fluid passes through the layers of media. Stratopore technology is used in air, coolant, fuel, and lube applications. It can have up to 5 layers and can be easily customized to fit a particular application. Notice the size and shape of the fibers in the different layers of the Stratopore media shown here. All of the synthetic layers have very regular shaped fibers. The coarse layer has large fibers and is not as dense. The middle layer has smaller fibers and is denser, but not as dense as the very small fibers on the fine layer. The fibers on the cellulose layer are irregular, but also fairly dense. It is important to understand that only filters displaying the Stratopore logo contain Stratopore media. In addition to the main or full flow media, some filters also contain stacked disc bypass media. This type of media is always used in conjunction with other media. It's used to remove sludge, the most common contaminant in a lube system. By removing the sludge from the oil before it reaches the full flow media, the service interval of the filter is extended. Filters contain only a few mechanical parts. The center tube supplies support for the media. It's usually made of metal, but can also be made of composite material for some applications. The metal or sometimes composite end plates are used for strength and to prevent damage to the media. Air filters use a different type of metal center tube made of expanded metal to provide support without causing restriction of the airflow through the filter. The thread plate or nut plate is how a spin-on filter is attached to the mounting base. The threads match the particular filter housing. The fit and finish of the mounting base and the thread plate are determined by the application. Gaskets are used to seal various parts of the filter. Some filters include new gaskets that need to be installed at each filter change, while others have integrated gaskets. It depends on the filter and the application. Finally, coil springs are used to hold the element seal against a gasket placed between the element and thread plate. They provide added protection against leakage. Now that you've learned the basics of filtration, you should know that the purpose of a filter is to remove unwanted contamination. You should know the difference between efficiency, which is the size of a particle filtered, and capacity, which is the amount of contaminant held by the filter. You should also know how filters are constructed, including the 3 types of media: cellulose, microglass, and stratopore. You should also be familiar with each of the other components of a filter, including the center tube, thread plate, gaskets, and coil springs. Cummins Filtration provides the broadest product coverage in the industry. Cummins has product solutions for air intake filtration, coolant and coolant treatment, centrifugal filtration, closed crankcase ventilation filtration, fluid filtration, hydraulic filtration, fluid analysis, and coolant test kits. To learn more about any of these products, you can visit our website at cumminsfiltration.com.